Hello, this is Professor Hester, and we'll continue looking at CCNA networking by looking at the physical layer. This video is part 3, where we'll look at the file media type wireless, and then look at a few summary questions about the different aspects of the physical layer that we've been looking at in all 3 parts. So let's do a high-level discussion about wireless media. CCNA networking digs into wireless networking in a lot more detail later on when you start learning how to configure wireless LAN controllers and learn a lot more about the layer 1 and layer 2 aspects of wireless. But for today, we'll look at some high-level aspects of it. First of all, wireless media has a few limitations. We have the limitations as far as our coverage area. A lot of times in a building, we may have interference from other items in the building, such as walls or other electronic equipment. We're concerned with security with wireless media. And then finally, wireless media is going to be a shared medium that's going to operate in half duplex. Our modern Ethernet cabling with copper and fiber optics operate in full duplex. That's not an issue for it, but wireless has some additional challenges. Wireless standards fall under IEEE 802.11. The older standards have letters like A, B, and N. And newer standards are going to be letters like A, C, and AX. Sometimes they're also given out as Wi-Fi 5 and Wi-Fi 6. And as the Wi-Fi standards continue to be developed, there will be new letters and new combinations of the names. When we're connecting to a wireless network, in an enterprise environment, we will probably have various access points installed throughout a building. And the nice thing about this setup is all of these access points are connected to a wireless LAN controller. They work together so that you can connect to one access point, roam through the building, and not have to re-authenticate as you move. Your connection will be maintained and passed off between multiple access points. So it's very convenient for someone. Now, with wireless communications, one of our issues is collisions. We could have 2 devices trying to transmit simultaneously. This is not an issue that we see with Ethernet, with our copper cabling. So what are we going to do about it? If we have a collision, the data from both of the devices will be corrupted, and neither devices will be able to successfully transmit their data. So what we're going to try to do is avoid collisions through a technology called CSMA/CA. It's a long acronym, but it stands for a longer phrase of Carrier Sense with Multiple Access Collision Avoidance. And how this works is, before a device starts sending data to an access point, it's going to send an RTS, or request to send message, to the access point. When the access point has the capability and can start receiving the data, it will send a clear to send message, or CTS, back to that host. Now the host can start sending the data, and as the data is uploaded to the access point can send acknowledgement messages. This strategy helps avoid collisions so that the data that is transferred to the access point is not corrupted and all of the hosts can transmit successfully. The nice thing is, with multiple antenna and the way channels are managed today, many devices can still transmit simultaneously, but CSMA/CA is going to ensure that even with multiple devices transmitting, they don't have collisions. So for our early journey in CCNA, this is a sufficient discussion of wireless networking. Again, we'll dig into this in a lot more detail when we start learning how to configure wireless LAN controllers. So now let's take a moment and look at a few quiz questions about the physical layer, layer 1. All right, in part 1, we discussed data movement terms such as a bandwidth and throughput. So which one is bigger, bandwidth or throughput? And the correct answer is bandwidth. Bandwidth is the theoretical maximum, while throughput is the amount of data we are actually able to move. Then we discussed twisting pairs of copper wires inside a copper Ethernet cable. So why did we decide to twist those copper wires? The answer is we are trying to minimize a type of interference called crosstalk. And while we're discussing interference, what is the other interference problem that we sometimes see with copper? That's going to be EMI. That interference comes from outside devices. Now with fiber optic cabling in part 2, we talked about single mode fiber and multi-mode fiber, the different characteristics between these types of cables. So which one can transmit data the longest distance? That would be our single mode fiber. Single mode fiber goes the longest distances and has the highest capacity. And finally, with wireless transmissions, when we have wireless networking, are we attempting to detect collisions or avoid collisions? Well, we didn't really talk about detecting collisions, but we described how collisions are avoided with CCNA CD. Other types of networking, such as copper, detects collisions. However, with modern equipment, we don't really have an issue with collisions. Collisions are primarily an issue with wireless transmissions, which is why we have the technology in place to avoid them.